Thank you, Glenn. Thank you, everyone. Thank you for joining this short presentation for the CRC Time Foundation project. As Glenn was saying, this is like a part one of two of these workshops. In this first part, I just want to give you an introduction about the project, what we've been doing so far, what we want to achieve, and in 2 weeks' time, we're planning to have like a second one where we can show some of the results of the survey that I'm going to talk about during the presentation, and then we can move from there with some more discussions about the results and how we can go on with the project. So my name is Rafael Picorelli. I'm a research mine engineer here at Mining Creek, engaged pretty much with a lot of holistics of and optimization and operational projects into the mine industry, mine to mill geometallurgy. And as other foundation projects for the CRC Time Program 3, we are trying to pavement the future research, trying to bring some innovative options at high risk points, and trying to increase positive post-closure legacies. And this is pretty much the case of this project. We're trying to further understand the different biophysical impacts of different mine methods used today, and what sort of the impacts that may change if new methods are considered. So as a little agenda for today, I'm just going to a short background, the project objectives, the methodology that we are considering for this foundation project, the mine methods that being considered, and some discussion about the survey that we want to conduct by the end of this session. So closure issues varies depend on mine method, creating different biophysical challenges on surface and underground. But in the other hand, mine method actually depends on the geology of the ore deposit. And usually the method is selected based on a pre-feasibility study. And there is a limit ways in changing this method once it's been implemented. If the ability to close the mine, reuse the landscape, and contribute to the community are to become driving factors in selecting the mine methods and mine operations, then they should also be considered in the early stage in the decision making. So what if we could rethink the way a mine method is decided, perhaps including the biophysical legacy issues as a more relevant factor in the feasibility studies? Or what if we rethink the whole way mine methods could actually work, perhaps like reducing the high amount of waste removed and treated? In this graph, you can see that moving and processing rock to extract a small percentage of valuable metal represent like over 90% of energy and 80% of the total production cost in the mine. This can be environmentally disruptive due to the large footprint that is required for processing and storing the waste material. Large-scale gang movement and treatment drive operational costs and set a high amount of grades required for mine method to produce in economical scales. What we are talking about here is some novel mine method that's being proposed to address this operational cost. Some of this novel include zero entry mining, invisible mining that leave waste in place and reduce ore movement. And since such technology could actually will bring like different technologies, this method will bring different technologies such robotics, such as cutting, leaching. This perhaps will actually bring a different set of biophysical issues that may affect the closure as well. So is this trade-off actually worth it? We need to try to quantify this biophysical impact of the current mining methods with like novel mining methods. So the objective of this project is try to understand the exist relationship between mine methods, closure, and post-mine land use. Try to evaluate the conventional mine method to identify closure challenges. Try to evaluate the novel mine method to identify opportunities to change closure options and highlight their own closure challenges. identify the new opportunity for post-mine land use for novel mine methods, identify the opportunity to develop mine methods that enable alternative close options. The aim of the project is basically to try to compare the biophysical closure impacts for conventional novel methods, identify if this new method could actually support a business case towards new mining approaches. By the end of this project, we plan to deliver a comparative matrix that could compare and contrast the biophysical impacts of those mining methods and highlight the current problems as enable mining methods to improve closure outcomes. The methodology that we've been using in this project is delivered through a desktop review process and workshops with the CRC Time partners, including the classification of closure impacts of a conventional and the expected issues of novel mining methods, literature review to understand what knowledge already exists in relationship between mine methods and closure, and the best way to conduct a classification of those impacts. The workshops, so we are conducting internal workshops, workshops with CRC Time partners like these ones, workshops and interviews with METs and mining people as government representatives, and a survey with those people to quantify the biophysical closure impacts in different mine methods. We developed a matrix of risks and opportunity, and up to now, we conducted a literature review that identified the typical biophysical impacts in the mine industry, and also identified the gap to quantify those impacts between mine methods. A template matrix was developed and will be populated with the outcome of the survey that I'm going to talk later today in the presentation. So the literature review shows us those as the more common factor as biophysical impacts. And we used a method to analysis using a matrix approach known as the rock engineering system, developed by Professor John Hudson at the Imperial College of London. The mining methods that we'll be considering here are listed in the schematic there, using the most common surface mine methods, the most common underground mine methods, and the novel in-place mining methods that we'll be talking a little bit more later today. So by the end of this, we'll be able to quantify the impacts of each mine methods, bringing like a good picture of like the hazard that a given mine method can actually bring regarding to biophysical impacts. So just moving through the mine methods that we are discussing and we are considering here, we have like the three major groups that I mentioned, and they are listed in this here. So starting with the surface mine methods, these methods extracting mineral near the surface of the earth. Waste and ore are extracted by removing the covering layer of rock and soil with a high material movement and a very low selectivity. You can see here a photo of a typical pit in Arizona, and these open pit mine methods usually is very traditional, this cone shape excavation, usually employed to exploit near surface, non-selective and low-grade zone deposit in horizontal exploration stages, also known as benches. It often results in high productivity and require large capital investments. Usually have like a low operational cost and a good safety conditions. It's a very typical process for multi-mineral applications with low to high grade content. The challenge with this mine in this schematic that you can see here is as you go in deeper, you eventually have your waste ore ratio going high and the cost to actually keeping the mine going and keeping like an open pit, you need to keep open the area, so you have like this strip volume keep increasing over time. And the other open surface mining that we have very common is like an open cast mining, and you have like a semantic there of like a coal mining. They are very similar, the open pit and the open cast. Both employed a near surface deposit, and it's also often a very high productivity. Major difference is that they are usually focused in tabular deposits such as coal, and when you're blasting those, you aim is to actually cast the overburden away, so you can access the coal. In this case here with a drag line. Both, as you can imagine, both, and probably you know, both generate like large amount of waste. And then we move to underground mining methods that, in the other hand, require further development to reach the deep deposit, because as the ore waste ratio stripping doesn't allow us to financially explore those deposits as like an open pit. But on the other hand, the ability to dig into the ore allows for better selectivity of what is to be extracted in comparison to an open pit, without the need of removing so much waste. From a geomechanical perspective, the underground mine method can be classified based on the type and degree of support required in the mine operation, with increase of rock movement as you go from a pillar supported to an unsupported method. And as you go there, you start to decrease the energy stress storage in the country rock. So we actually have some intermediate methods not listed in this schematic, but we can say that the ruin pillar and caving methods are the extreme methods in these ranges. So just starting to talk about the ruin pillar. This method includes creating open areas within their ore body and pillars of rock at consistent intervals throughout the open area to support the rock structure above. After mining out the ore within the area of the pillars may be removed for safe collapse and fill to take place, not usually using very deep mines, as the width of the pillar would be too wide to support the stress and won't be viable. And we have like the stope mining. There is a variety of stope mining available: open stope, sub-level open stope, cut and fill stoping, shrinkage stoping, and pretty much consists of drilling and blast material and leaving behind an open space known as a stope. Stope is used when the country rock is sufficiently strong to not collapse into the stope, and the material is then collecting from a draw point in the bottom of the stope. This mining method is relatively safe, as the mine actually retreats back from the previous mine area or unsupported area in the underground mine. Then we move to the unsupported technologies, starting with the block caving, the caving mine, that is focused on undermining the ore at locations where it will compromise the structure, integrity of the ore, and then forcing it to collapse on its own weight. Once it's compromised and has fallen, it is excavated by the bottom with some equipment, and this method is effective. Is usually require very low cost for operation than like conventional method of mining, although you need like more preparation and it's very difficult to access. The other method that we have unsupported is what we call the longwall mining. Is a mechanical excavation of coal from tabular deposits, also to like soft minerals as potash. When you have like large rectangular blocks of coal defined during a development stage of the mine, and then extract at once using equipment like those. to cut the face of the coal in this case. Both methods actually bring some very typical impact in the surface with like some subsidences on the soil on top of it. And then we go to the in-place mining. Mining 3 is actually leading this initiative called in-place mining, which is motivated by the concept of minimal rock movement and processing in place. So the in-place mining will deliver like a small surface footprint, trying to reduce tailing generation, trying to bring like high automation and a low capital intensity in the mine. So the in-place mine is actually a group of three main areas, starting with what we call the inline. And the inline recovery concept aims to selective mine and ore upgrading. So pretty much for underground mining. And they try to concentrate material that is transported to a process facility. The mine methods incorporate technology that can be employed at or close to the face of the selective mine and pre-concentrate the material, reducing the need for haulage of the material to the surface to be processed. Some of the technologies that are in this area include the Dynacut, some mobile crushing and sorting units, and sensing and preconditioning technologies being developed. The next one is what we call the in-mine, that will try to minimize rock movement and fracture or using blasting, hydraulic, or other ways in underground. So the idea is to generate a conditioned mineral block that can be leached underground. So for example, CRCO have the remote ore extraction system that use remote automated horizontal drilling and blasting, allowing to create like an underground leaching reactor for massive leachable deposits. And that's not all. There is like other possibility of like some hybrid methods where the high grade could still be treated in the conventional way, and like low grade areas in the deposit could actually be dumped, leached, and in such underground reactors, increasing the recovery at deposit and keeping like the material movement to the minimum. And even like the idea to revisit like some brown fields with unsupported underground mining methods to perhaps try to extract some residual value in the remain ore without the need of all the capital cost, like bringing like more value to a deposit, for instance. And the third branch of this in-place approach is what we call the in situ. Traditional in situ leaching is well-known low-cost method for commodity extraction that does not depend on rock movement. The ore is processed in situ in surface operations. But like I said, that's like a well-known method. So why this concept is actually be considered novel? You probably know that there is like a lot of social and environment concerns to conventional acid and cyanide lixiviation. So one of like the key enablers for revisit these technologies is we have now developed new lixiviants like that are no toxic, no volatile reagents, able to leach both base and precious metals without taking gangue minerals into the solution. And depending on the condition, you can actually have those to be reusable in the next in a closure environment. So as a way to continue with this work to gather information systematically and quantify it, we would like to ask you to participate in this short survey in the link that I will provide today after the meeting. The information that you provide will be used to fill the matrix that we present earlier today and support the goal of this project. This survey has been designed to investigate and compare the biophysical footprint of different mine methods And we hope that your experience and expertise can help us out identify the many issues associated with different mine methods for closure and post-mine land use purpose. The survey is very short. It is only expected to take like 10 minutes. And we would really appreciate in advance your time and participation in this survey. Especially if you have someone else that you would like to send the survey through, we actually incentivize that to happen. Well, that's all for me. Thank you. And if there is any questions, I'm happy to answer.
Thanks very much, Raphael. That was yeah, a great presentation. And so, look, I mean, I know we're nearly up to the half an hour. So if people do need to go, that's fine. But we will send you the survey links. But we will keep it open a little bit longer if people have some specific questions that they would like to raise now. Sorry, we can't seem to unmute the chat line, so we can't allow. You won't be able to use the chat line, but if you would like to ask a question, please just raise your hand, and I'll just speak directly and put it towards Raphael. So, does anybody have any questions that they'd like to raise with Raphael? Okay, I'm not seeing anybody's hands go up, or I'm not hearing anybody.
I'll take any questions offline if they want as well. Yeah,
so if you'd like to give questions offline, that would be good. Our intention, what we will do, somebody's put their hand up, but I'll just mention this, is to run this 1 hour workshop in 2 weeks' time, and we'll do it at the same time, I think, Raphael. So that's the plan. I don't think we've given people a time, but I can't remember. Maybe we have, but we will run it at this time. So 9 West, 11 Brisbane time, East Coast, or 10:30 Central time. Sylvia, you have a question. Okay,
yes,
thanks.
Thank you.
Can you just introduce yourself too, Sylvia, as well? Where are you from?
Okay, yeah, Sylvia Black. I'm from Chem Centre in WA. It's a government scientific organisation. So my question is, with the different mining methods, are you also looking at the amount of and type of waste that the methods are generating, and looking at minimizing the waste generation and probably repurposing of those? Is that?
We want to quantify the impact in a systemic way, because you can actually be generating a lot of waste or particular waste, but there is like a lot of other benefits of like that given sort of mining methods. So if we could actually put all the impacts in the same structure, we can just check if like perhaps, okay, there is a lot of waste being generated, but there is like some pros about the going to this method.
Yeah, so would you extend that to look at how you can repurpose the types of wastes? Because even if you generate a lot of waste, you may be able to, different types of waste, you may be able to repurpose better than others.
Yes, for sure.
Is that something that you might be looking at? Or?
Yes, that's part of like what we are trying to yeah.
I think, Sylvia, that would be something that we'd be looking to do over the CRC. I guess within the scope of this project, it is only the beginning, but a fair question.
Okay.
I think it's Ewan Sellers here from Mining 3. We've been doing quite a lot of that work in other projects, and there are definitely a lot of possibilities. So it's clear in our mind of how to link this in. So it's interesting that you connect. You've raised this issue, and maybe we could have a chat offline about how you see the significance and some of the other stuff that we've been doing there.
Okay.
That's great. Thanks, Ewan, for coming in, and Ewan's also a key part of the project as well. Right. Does anybody else have any other questions? Now I'm going to give you a couple of seconds to think about that. Ibrahim. Sorry, Ibrahim, would you like to? You've got a question?
Hey, Glenn. It's not actually a question, just to complement what Raf and Ewan mentioned. And for these new mining methods, like
Abraham,
in-mine recovery.
just let everybody. You are just say you tell me if you are from Mining 3 as well. Just let.
Oh yes, I am. Yeah, yeah. Sorry.
That's okay. Go ahead. Sorry.
Yeah. So for this new mining methods like in-mine recovery or inline recovery that Mining 3 is promoting, actually, we are looking at repurposing waste as a rockfill material. So waste will be used, for instance, for underground mining to fill the stopes and to ensure that those excavated stopes, they will remain stable for the next phases. Just to say that some of these mining methods inherently include that waste valorization inside.
Yep. Okay. Good point. Thanks, Abraham, for that. So I can't see any other questions coming up. Abraham's still got he's put his hand down, or he's about to put his hand down. Look, I just wanted to say thanks everybody for coming online. I hope you found that useful. I found it really interesting, actually. It was a great presentation and good summary of a lot of different mining methods. As you said, we're going to have the follow-up workshop in 2 weeks' time, but please do complete the survey. We'll send that out so you can get through that survey link. So thanks from me, and I'm sure Raphael, did you want to say anything in conclusion?
No, I just would like to thank as well. If you have like any offline questions, we're happy to chat, and feel free to actually forward this survey to anyone that you feel like will be relevant and could actually bring some good insights to what we try to achieve here.
That's great. Thanks everybody. Thanks for your time, and look forward to seeing you in a couple of weeks' time.
Thank you.